One of the exciting things about being a researcher so close to Silicon Valley here at Berkeley is that give and take between industry and academia in terms of pushing technology forward. It's our role in academia to try to look out 5, 10 years and see what's coming and do new things. And so when the Postgres project started in the 80s, it was doing that. It was well ahead of where the industry was. Postgres as a platform is the most full-function database in the open source arena, and it has been for quite a long time. And the emphasis in the Postgres project has always been to sort of build out a complete suite of engine technologies inside the system. And this is in contrast to MySQL, which was trying to build a lean system. So when you're going for a very high function platform and you're trying to build the kind of thing that Greenplum is building, you want to start with a platform that is full featured to begin with, and then enrich it with all the scalability, all the performance, all the reliability that a commercial product needs.
What Greenplum brings beyond a base Postgres system that you get is really scalability, just that you can handle enormous amounts of data. And it does this through a range of different technology, different kinds of partitioning, ways of exploiting parallelism, ways of exploiting the wonderful new hardware platforms that are coming out these days.
There's been a long back and forth battle in the database industry going back to the 70s between the idea of building hardware accelerators that make the database go faster and following the trends that just commodity hardware can have in terms of getting faster simply through market presence and through growth. And over time, what we see is that the commodity solutions have won every single time. People have investments and relationships with technologies that are components of a database system. And the ability to be flexible in the way you cobble together the pieces of the system comes for free when you design for commodity to begin with.
The company was just incredible what it achieved in a small amount of time with a small number of people. And part of that, of course, was starting with the Postgres system. Part of it was the great talent that was involved in the people that had taken it from a uniprocessor database system to a shared nothing parallel system.
The ticket to parallelism, the place you start is data parallelism, because it's much easier to think about doing the same task over many data items. This is a big change because programming was traditionally taught as you start with a little data structure and you write a sequential program that traverses that data structure. We're really revisiting these ideas in academia, and at the heart of what's getting revisited is large data management. Greenplum's got a remarkable engineering team, actually. You've got industry veterans from essentially all the major database vendors that have been around for the last 2-3 decades.
What I think Greenplum brings to the market now is an incredible price point for people who need to work with huge amounts of data and want full SQL over that huge amounts of data. Historically, it's been extremely expensive to try to do that if you can do it at all. And Greenplum makes it much cheaper to do that kind of thing.
Greenplum is somewhat unique right now, I think, in being at the same time a very high performance, enormously scalable system that can really build out big installations, and a relatively modest-sized, nimble company. So most of its competitors are essentially these very large companies with enormous engineering organizations and a lot of responsibilities to legacy customers. Greenplum's going to be able to innovate and move a lot faster, I think, in many respects than those companies, simply for business reasons. And that combination of technology and agility is unique.